1, go. Hi everyone and welcome to my Go course. Today we're gonna talk about variables. So what are variables? When working with code, when programming and coding, we want to use some data, we want to work with some data, want to store it, modify it, access it in any possible way, and so on and so on. So the way to do this is by using variables. So in Go, you can declare your own variables, for example, by using the var keyword followed by the name of a variable, for example, I, and the data type. In this case, I use the int data type, which stands for integer, and this is the very simple declaration of a variable. So now it's completely declared and it can be used. And as you see, my text editor complains because the I was declared and not used. And if I try to run this program by typing go run and the name of the file, then I'll see that the same, it's declared but not used because Golang compiler prevents you from reserving some memory for the variable but not using it. In this way, Go saves you the memory, and that's why let's go and use this variable. Go. For example, I would like to print the value of this variable, and let's see what will happen. We'll run this once again, and we'll see that the variable has the value 0, but I didn't assign it any value. So how did it happen? You can think of a variable as a container that holds a value, but here I didn't assign any value to this variable explicitly. So how did it happen? In Go, there is a thing that any variable you declare, it's assigned a default value. In Go, we call it a 0 value. So for example, for this integer variable, it's 0. And Go prevents you from having unassigned, uninitialized variables. For example, if you know some other programming languages, then, for example, programming language Java, there you can create a variable without initializing, and then uh, you can run it and you'll get an error because the variable wasn't initialized. So Go prevents you from doing this. But okay, let's move on. And what can we do with this variable? We can assign it a value, for example, 10. We can um, reassign it, sorry, reassign it, for example, minus 20. And the very important thing, I can only assign the variable, the value of this variable according to its data type. Because, for example, if I try to assign it a string literal and say hello, it will complain because the hello is a string literal and my variable is an integer variable and it can only hold integer values, which is um, this happens because Golang is a statically typed language, not dynamically typed, comparing, for example, to Python. In Python, you can reassign the value of a variable and give it a different data type. But Go is a statically typed language. That's why you should be aware that you can only use the same data type. And this happens, for example, if I try to assign a floating point number, let's say um, 45.6, it will complain because it's a floating point number, literal, and it can be used as an integer variable. Okay, so uh, let's move on. This is not the only way to declare a variable. And actually, if I know that um, if I would like this variable to have an initial value, I can assign it straight away by writing it like this. And if we run this program, we'll see in the output 10. So this variable was declared and assigned the value straight away. And for this kind of assignment, there is a short version. For example, I can instead write it like this. I is using the declaration and assignment operator is equal to 10. And in this way, I declare a variable and assign it a value at the same place, at the same time. And if I run it again, I'll have 10. Please do not confuse this operator with the assignment operator, because if I just write this code, it won't compile, it will fail, because I is undefined. It hasn't been declared before. So I either need to declare it as an integer, for example, and give it a value, or I need to use this operator. So actually, I mentioned before that when declaring a variable, you need to give it at least a name, a valid name. There are Go guidelines. There is a Go specification which specifies the valid format of a name. For example, the name cannot start with two or like with numbers, because it's an invalid variable name. So a valid variable name can only start with um, alphabetic characters and not numbers. But if you're interested in this, you can check the Go specification regarding the variable names. But let's move on and talk, for example, what happens here if I write this operator and if I write some value, some literal. For example, in this case, I'm creating an I variable and assigning it 10 value by using the number literal. And I mentioned previously that when you create a variable, you need to write the name of the variable and its data type. So how does the Go compiler know which type this variable has? The Go can guess it. The Go should guess it actually during the compilation, and it can do this by, for example, checking the data type of the literal. And it's easy because this literal is an integer literal, and that's why it has a data type of integer. So if you see here, it's the name is I, and the data type is int. And we can even prove it by printing it using the printf function of fmt package. And what this function does, it takes a string, a formatted string as an input, and this formatted string can contain templates. For example, um, we can write var and use the decimal number template to print the decimal number. And then we write as a second parameter the actual number. And if we run this program, we can even write here a break line so that it prints the next line. And we see that it printed var 10. So what happens during what this printf function does, actually, it resolves this template d, %d, with the value of this integer variable. So, and why am I using this printf function? Because I can prove you that the data type of this variable is int. So we can write type and use the type template, and we'll use the I again. So this template will be resolved by the value of I, and this template will be resolved by the data type of I. And we run it again. It says var 10 and type integer. Okay, so if we try to assign it, for example, a floating point number, and let's run it and see what will happen. It complains because it's not a decimal, so it's not an integer number, and actually this is a float, which with the value of 23.6 and type float 64. Okay, so this is my mistake. I need to change this template to F for floating point numbers. And if I run it once again, it will give me the correct value in the output. Yes. So what else? I'd like to show you another example of a variable declaration. For example, if you have several variables of the same data type, and you know that they correlate or you can logically combine them, then you can declare them using one line. Just, for example, writing this kind of code like A, comma B, comma C. So you separate the names of the variables by comma, and then you can write their data type. So, and they are declared but not used. That's why it's complaining, but this is fine. And then later you can assign them some values like B is equal to 10, C is equal to minus 34, and now it's fine. And there is even, if you know by the time of declaration, you know the values or the initial values, you can even do this straight away on the same line by using so-called tuple, a tuple initialization. So you can write like this kind of code, minus 3, minus 4, and 34. And it also works. And there is also a short form of this. For example, you can write it like this. And in this way, you declare all three variables and assign each other a value. So in the same order as these variables are declared, they will be assigned these values. So A will be assigned the value of 10, B will be assigned the value of 4, and C will be assigned the value of 34. And we can see it by printing these values. I'll use the printf function, and I'll write val and the decimal template, and then type, just because I would like to know its type, and the break line character. So first I'll do this for A, and the same I'll copy, paste for B and for C. So let's run this code and see what will happen. So yes, these variables were declared in this order, and they were assigned these values in the same order. Great. Another example I would like to show you is, for example, A. Previously we wrote the code like this. A is declared and assigned the value of 1. And in this way, by using the integer literal, the Golang compiler will guess that the data type of this variable is int. And it doesn't necessarily have to be a literal. It can be, for example, an expression. Let's say we have two variables, A and B, with the values of 1 and 34, and we declare a variable. We need to declare and assign it, and there is a variable C, and which is a sum of A and B. So what will be the data type of C? If we print it out, so val, let's use the V template, which means the value, and T template for type. So because we would like to know which data type this variable has, and we forgot the break line. Yes, and let's run this code. And it says the value is 35, which is the sum of 1 and 34, and type is integer. How did it happen is that we don't necessarily have to use an int literal or any kind of literal like string literal or struct literal, because the Go will guess the data type by the data type of the result of this expression. So this is an arithmetical sum, a plus b, and the result of the sum of two integers is an integer too. And the same happens, for example, if we divide a by b, and the result of the division in Golang, the result of the division of two integers is an integer. So if we run this kind of code, it will say that the value is 0 because it's basically a division without remainder, and it gave you just a 0, and the type is still integer. So this is how Go can guess what type is it. Also, if you, for example, if you use, you can call the variable can be assigned a value also by calling a function. For example, we can use some function from the math package, and we will import it here. And we can use some function from this package. Let's say, for example, logarithm function, and it will be assigned a value of, let's say, 34.6. And so what will be the data type of this C variable? If we see, so the value is 3 and something, and the type is float 64. How did Go guess which data type this variable should have? Is by the declaration of the function. So if we check the declaration of this function, it has the name of log, and this is a function which accepts a parameter of float 64, and it returns float 64 value. So by the returning value of this function, Go can guess which data type this variable has. Okay, sometimes you can also see this kind of code, because previously I showed you the tuple declaration of, of variables, and it's pretty common to see this kind of code in Go. If you work, for example, with files or some functions, functions can return multiple values, not just one single value, but multiple values. And you can use those multiple values in this tuple declaration. For example, you'll probably see this kind of code. For example, if you want to open a file on your computer, on your machine, then we can use the OS package from the standard library of Go, which has utilities to work with the operating system, with environment variables to read and write, to read from files and write to files. So in this case, we'll use the open function to open a file, and the open function accepts a string which has the file name, let's say text.txt, and it has a returning type. It returns two values actually, and the first value has a type of pointer to a file, and the second value is an arrow. So we can use those values in the tuple declaration. For example, I'll call the file pointer as f, and arrow will be just arrow. So great. And now we can see that f has the data type of pointer to file, and r has the data type of arrow. And usually this is very common practice in Go. If you have this kind of code, you should first check the error. If the error is not equal to nil, so if it's not empty, then we need to handle it in some way. For example, fmt print line error occurred, something like this. And we need to, for example, we can panic, say panic. And this panic function will basically stop the execution of the whole program and return a non-null value, which means that the program was executed not successfully. But in the case if this error is nil, we can still work with this f, for example. But never forget, if you open a file, to close it at the end. After you used it, close it, because your operating system usually, when you open a file, it gives it a file descriptor, which is an integer number. And if you forget to close your file, and if you read multiple files, the situation can happen that your operating system runs out of file descriptors, and it will be pretty and very painful. So do not forget, never forget to close your file. So, and we can run this code, and we see that there is error occurred, panic. Why did this happen? Because we tried to open the file that doesn't exist. So let's try to create it. Text.txt, an empty file. That's fine for us for the sake of this video. And let's try to run it again. And now it executed successfully. And let's actually, after this, print something to the console. fmt print f, and value, let's say it will be v template for the value, and the data type of this, let's check file and file, and let's run it once again. So we see that the value is some um, internal representation as a string of this file pointer, and the type is OS file pointer to a file. Great. So this is a very common practice in Go. You will see many times this kind of code. Another important thing I would like to mention is the scope of the variable. I can talk about this for a long time to explain you many different cases of the scope of the variable, but for the sake of this video, let's just have a simple example. For example, we have a variable s, which has the type string, and later on in the code, we assign it some value, like for example, hello, and print it out. Print. Let's use printf and print the value of it using the s template for string and the type t template. So s and s. Printf. What's wrong? So I have two literals, just like this. Correct. So let's run this code, and we'll see that the value is hello and type is string. I forgot to print the next line. Okay, let's run it again. Hello and text, the type string. So the value, if it's declared, once declared, it has a scope. And the scope is limited, for example, by the scope of a block. For example, it's declared within the main function, and its scope is limited by the main function scope. But let's say, for example, we have a block, for example, if statement with some, let's say, true. That's fine. And this if statement, it has these curly braces, and these curly braces define a block. So here, a new scope, like if scope start, and here is if scope end. So if we try to use this variable here, we can actually use it because this is an outer block for us, an outer scope, and this is an inner block with like an inner scope. And from within this inner block, we can access the value, and we can access this variable and reassign it value. For example, say buy. And what will happen if we run this code? The value will be buy because here we declared it, here we assigned it a value of hello, and in this block we reassigned it. But what will happen, for example, if we declare it with this value? And here it says the s declared but not used. So we declared it once here and assigned it a value, and here we also declared it, and this variable now it's only available in this scope because it was declared in this inner scope, and it's not available in the outer scope. We can Now it says it's not used. Let's use it and print it out. Let's just copy this whole line and run the code again. So now we see that inside of the if block, we have the value by, but it doesn't affect the value of the variable in the outer scope, even though it has the same name. And this thing is called shadowing. So this variable, which is declared in the inner block shadows the outer um, block block's value, block variable s, because it has the same name. And this is a common mistake, for example. Be aware of this. Because if you really want to update the value of this variable or to change its value of this variable, you should use this operator, the assignment operator. But if you need to declare it, you need to use this variable. And for this purpose, I would like to recommend you to use a different name. For example, s inner, because it will be confusing if you use the same variable name in the like in the inner block, within the inner block. So this is uh, about the scope of the variables. Move on, and previously I mentioned that, for example, if you have a variable I with a data type int, you can only assign it int values. So it cannot be assigned anything else like a floating uh, point number value, because um, the range of values for this variable is defined by its data type. But there is a way to overcome this, because Golang has different data types. For example, it has basic data types like integers, unsigned integers, string, floating point numbers, and so on and so on. It has also some composite data types like arrays, structs. Um, it has some reference data types like slices, for example. It has also pointer data types that are references to a particular place in the memory, and it has also interface data types. So this is what I'm going to demonstrate you quickly. For example, we have a variable I, and its data type is empty interface. Yeah, this is a valid expression. So it's declared, but it's not used, but it's a valid expression, and I can later assign it a value of, for example, 20. And it's a valid expression. And then I can reassign it a value and say, let's say it's hello. No problem, doesn't complain. And then I can assign it a value, for example, using a composite data type struct, and I can assign it a data and an empty struct literal, and it doesn't complain. I can even say it's gonna be an array of floating point numbers, float 64, which will contain this number, actually several numbers, and it doesn't complain. I can even say I, and its value will be a function that returns nothing. No problem. No problem at all, because this data type is an empty interface which has no methods, and this means that any value of any data type, actual data type, can satisfy this interface. So it doesn't complain about the value, it only complains that this variable wasn't used. We'll talk more about all of the data types in Go in the next lessons, and specifically about interface data types also. But for now, for this video, this is fine, just to know that this code is valid too. And if you use the interface uh, data type variables, any value that satisfies this interface data type can be used. So, and previously I also mentioned that in Go, every variable is assigned a zero value if no explicit value is assigned. For example, if we declare a variable of string, it seems to be with that it seems that we didn't assign anything, but actually it has a zero value, and the zero value um, is defined by the data type. So every data type has a zero value. For example, if we print this out, print f, we want to see the value and just value. And we also want to see the data type. So S and S. Okay, let's run this code. Yeah, and the value is nothing because it's an empty string, and the type is string. So actually, every data type in Go has its zero value. For example, for an integer data type, the zero value will be just zero. For a float data type, let's say it has the data type float 32, it will be also 0, or let's say 0.0. And for the string data type, it will be just an empty string. And for an interface data type like um, interface data type, it will be just nil. And what else? We can also say, for example, there is a specific data type which is not, uh, there are specific kind of variables that do not hold the value directly, but rather they hold a reference, an address of the memory where this data is located, and this is a pointer data type. For example, we can create a pointer to integer, which will have this data type, and its value will be nil also. So you should know that every data type in Go has its default value. So be aware of this. So this is pretty much it for this lesson. If you want to know more about variables, you can read the official documentation of Go. It's very good and it has everything, and you can dive deeper if you want to know more about the variables. But this is it for this video, and hit the like button if you liked it, write a comment if you want, and please subscribe to the channel. Thank you and see you in the next one.